Okay. So we are discussing about intermolecular forces.
Mm-hmm.
So first of all, I have a question for you. Suppose there is a water in form of ice. Water can exist in three forms. Yes. What are those?
Ice,
Yes.
water,
Water.
and what is this third one? Like the gas form.
Gas form is water vapor.
Mm-hmm.
Water vapor. Okay. So can you tell me slightly in depth, like what is the basic difference between all these three forms?
Ice is a solid, water is liquid, and water vapor is a gas. And then like in water vapor, I'm pretty sure like the molecules are really farther apart.
Yes. Very good. And
And then in ice, they're like more closer, like they're really close together. And then in water, they're like in the middle.
great. And in solid?
What do you say?
In solid,
They're like the molecules are really close together.
really close together. So what this is going to do on the nature of the water? Like is this really a relevant thing? Like okay, why they are so closer in solid?
Is it more dense?
It is more dense. Any other reason? Like why the molecules are like uh, closer together? Here it is very far. Water is same. Like the formula for every each of the following three cases is H2O. Yes, but the
Mm-hmm.
pattern of the molecule is different. Arrangement of molecules is different. So in solid, the intermolecular force of attraction is high. Maybe you have already gone through it. And in liquid, the intermolecular forces are slightly lesser than solid. So the molecules can move here and there. That's why water can flow. Mm. And in gas, they just
Okay.
move very far. Like you spray perfume in your room and the fragrance goes to the next room. Yes. So they can
Yeah.
flow very fast. So now we have just arrived from chemical bonding. So in chemical bonding, like we know that there is some force that holds two molecules together. Yes, like if I talk about H2 plus Cl2, and it is giving me hydrogen and chlorine is giving me 2HCl. So this hydrogen chloride molecules are together. This is atoms, not molecules. Cl atom and H atoms. So this is bonding is like something, some force which is existing in between the atoms. Yes. Now we are discussing intermolecular force. So it means we are going to talk about something, some force that are holding molecules together. Yes.
Mm-hmm.
Okay. Now see, again a question from me, like what you can do to go from ice to water. Yes, if you want to go from, if you have a ice in your hand or beaker, so how can you make it water? Hello. Yes.
It'll melt by like your body temperature.
Body temperature. So, like what chemical process is going on? Like what you did, you supplied some heat, some energy.
Yeah.
Okay. So
Yeah.
you supplied some energy, or you can say like enthalpy. Yes, or heat. So
Mm-hmm.
it became water, liquid water. Now again, from liquid water to water vapor, if you want to convert something, what you do?
Liquid water from water vapor.
Like from water to gas, liquid
Oh,
is
you just
right?
you just
Yes,
heat it again.
you just heat it again. Okay, have you done this thing at your home?
What did you say?
Have you done this thing at your home?
Yeah.
Yeah. Okay. So have you noticed like the both see because either I am going from ice to water or water to water vapor. Both are involving
Mm-hmm.
change of heat. Yes. So my question to you is, will the heat in both of the two cases will be same?
No.
No. What is the reason?
Well, to heat it from water to water vapor, it needs to be hotter than to heat it from ice to water.
Yes. You were saying like ice to water, it can be done even with body temperature. Like if you are holding
Yeah.
tissue. Yes, but from water to water vapor, you just take water, you boil water, and then it reaches its boiling point. Then it becomes like it just becomes vapor. So it means it requires a lot of heat. So my question to you is like if why what is happening when you are applying energy to this one, like heat to this one, in terms of like intermolecular forces, what is happening?
Um, the bonds are being broken?
Yes, these forces are just like very strong in case A, and in case B, what is happening? These forces are loosening up. Yes, molecules are now not very close together. Okay, intermolecular forces are becoming weak, and now from B to C, it is becoming more weaker. Yes. Now my
Mm-hmm.
question to you is, if it is all concerned about intermolecular forces of attraction, so why this heat is very very high? It should be same as it is given in the transaction A to B.
Um, it requires more energy to split the bonds.
No, there is no bond. See, here the molecule is also of H2. Here the molecule is also of H2, and here also H2. So we cannot talk about bonds. And I already told you like bonds are formed between the atoms, H and Cl.
Okay.
So why so much energy? And if I give you the stats like some scientific value, uh, to validate my point. So this ice to water is known as fusion. Okay, and the enthalpy, standard enthalpy for fusion is 6.02 kilojoule per mole for this process.
Mm-hmm.
And for this process, the energy is del H vaporization enthalpy, and this value is 40.7 kilojoule per mole. So see, there is a lot of difference, not slight difference, lot of difference between 6 kilojoule and 40 kilojoule. So my
Yeah.
question to you is, why so much large energy is in the conversion of B to C?
Uh,
It should be nearby. If it is 10, 12, okay, I can digest, but why it is so large? That is the real question. So do you have
I
an idea?
don't know.
You don't know. Okay. So the reason is maybe this is not about intermolecular forces. Yes, if it is only concerned about intermolecular forces, it should not be like the way is as it is. Yes. So there will be some other forces which are playing role here other than intermolecular forces of attraction. In this case, especially in this case, because lot of energy is required here.
Okay.
Yes. So these molecules are attracted or associated or like have stronger inter molecular forces due to H bonding, due to hydrogen bonding. Some scientists have
Mm-hmm.
like studied this case and they have found it due to H bonding. Maybe it is a new to you, new thing to you. So due to H bonding, these molecules are much closer to each other. Yes. And what is this H bonding? When hydrogen has very small size, It is the first element. And when
Yeah.
hydrogen is attached to either oxygen or either fluorine or either nitrogen. See, oxygen, fluorine, and nitrogen are very electronegative elements. Yes, most electronegative elements. Fluorine is the
Mm-hmm.
most, and then oxygen, then nitrogen. So they are very highly electronic elements and they have a small size, high electronegativity and small size. So whenever hydrogen combines with these three, either oxygen or maybe fluorine or nitrogen, so it forms a new bond that is known as H bonding. You know, covalent bond, you know, ionic bond. This is H bond, H bonding. Yes. So it means like, suppose we have a water molecule, HOH. Yes, this is how water molecule looks. Okay. So this hydrogen can be bonded to next oxygen like this. Yes, and this bond is known as H bonding or hydrogen bond. Got it?
Okay.
Okay. Do you know this like earlier?
Yeah.
Okay. Now again, this is again one more H bonding. Now this oxygen also can bond with, sorry, yes.
Yeah.
So the point is a single water molecule can make four hydrogen bonds. And you may get a question like how to draw this as well. So, okay, four hydrogen bonds. So what is happening here? Due to this hydrogen bonding, are not you thinking the molecules should be far apart in liquid, but they are close. Why? Due to this hydrogen bonding, the molecules get
Mm-hmm.
associated, and when they get associated, when they are close together, they become more liquid. Yes.
Mm-hmm.
See what is difference between gas and liquid? In gas, the molecules are far apart. So how can you make a gas again liquid? By condensation? Yes. So by
Mm-hmm.
increasing the molecular gap. So when molecules are associated, it means the thing is moving backward in this direction. Okay. Due now to separate these water molecules, what you have to do, you have to separate not only these molecules like H2O, H2O, these molecules are there, suppose. Not only you have to separate these molecules, but you also have to break down the H bonding, these bonding. Yes, and that's why extra energy is needed to break this bond, and that's why it is 40.7. And hydrogen bond is usually a strong bond. Yes, it is between 4 to 40 kilojoule of energy. Yes,
Okay.
it is a strong. This is one type of bonding. Again, due to this hydrogen bonding, not only molecules are associated, they get access to dissolve in water. What do this mean? Now you know, water is a polar solvent. Yes,
Mm-hmm.
water is a polar solvent, and uh, my question to you is: can NaCl be dissolved in water?
Yeah,
Why?
because I don't know.
Because it can break into its ions. Yes, water is polar. NaCl is also polar. Like it has some polarity. Yes, so like
Okay.
dissolves like. There is a funda in chemistry. Like dissolves like. So that's how it can dissolve in water. Okay. Now my question to you is again whether this one, I don't know the name, we have forgotten. So can this dissolve in water?
What can dissolve in water?
This
Oh,
one.
that.
this thing.
So I'm pretty sure that's non-polar, so no.
Yes, it is non-polar.
So it can't dissolve in water, right?
It cannot, yes. But it dissolves in water. You know, alcohol dissolves very well in water. Sanitizer, you know, hand sanitizer contains alcohol. So it dissolves in
Yeah.
water. So why it is so? Why the partiality is there? Covalent compounds are supposed to be like uh, not dissolving in water. But now this alcohol is a covalent compound, and actually you're surprised it dissolves quite well in water.
Oh.
So why it is so?
Mm,
Due to H bonding. Due to H
okay.
bonding. Due to this H bonding, molecules get access to dissolve in water. Yes. So how? Because it is having one oxygen and water is having, got it?
Yeah.
So how can hydrogen bonding be formed? By this, like with oxygen, with fluorine, and with nitrogen, it can form. Like suppose if fluorine I am taking, here it is HF. Now, maybe the pattern is wrong, but it looks like this one. HF, HF. Yes, like this one. So it means this is the H bonding. So due to H bonding, the molecules are associated. First point. Second point, the molecules can dissolve in water. Yes. And the third point, the biggest point, the boiling point is raised. Third point. Yes. So these are three consequences of H bonding. First is they get associated, they get access to dissolve in water, and third is boiling point is raised. You know, there is a table, there is a very good table or graph that says like H2O, H2S, and we have NH3, we have PH3, we have HF, and we have HCl, we have HBr, and so on. This goes on. Yes. So this first element, first molecule is having the highest boiling point in the group. Hello, are you there?
Yeah, I'm there.
So this is a really very see boiling point depends upon molecular weight. Boiling point depends upon molecular weight. As the molecular weight increases or the molecular mass increases, as the molecules become heavy, the molecules are supposed to have higher boiling points. Yes. In
Yeah.
in this case, H2O is having lower molecular mass than H2S. NH3 is having lower molecular mass than PH3. HF is having lower molecular mass than HCl than HBr. However, they all these three are having still they are having highest boiling point. So what is the reason? Not highest boiling point, like high boiling point. So what is the reason? So reason is because they are making H bonding, molecules are much more closer to together. They are associated. So we need to apply much more stronger force so that molecule like liquid can change into gas.
Okay.
If H bonding was not there, H2O will be a gas. This is also a fact because H2S is a gas. This is a gas. So this is liquid only due to H bonding. If H bonding is not there, you know, we cannot drink water. Okay.
Okay.
So this is the H bonding. Now next thing to you is okay. See HCl and HCl. They are two molecules. When they come closer to each other, they get some attraction, and this attraction is due to the dipole. Due to the dipole. Yes, and what is dipole? You know, dipole is when there is a electronegativity difference between the two atoms. What happen? There exists partial negative and partial positive charges across the two ends. You know this?
Yeah.
Okay. So now this negative charge and this positive charge have some electrostatic force of attraction or have some force of attraction, and this is known as dipole-dipole interaction. Due to this, molecules come closer together, but this force is not so strong, yes, as the upper one we have discussed. So this is also a strong force. Dipole-dipole interaction. Due to polarity between the two molecules, the molecules get associated or get closer together. Got it? And this happens due to electronegativity difference or
Okay.
polarity. So Cl is having electronegativity around 3.0 on Pauling scale, and H is having electronegativity of 2.1. So there is a good electronegativity difference. Now, if I take H2 and H2, like these molecules are non-polar. Yes,
Yeah.
and they also interact with each other. They have some weak attractive forces, and these are basically known as van der Waals forces.
Okay.
These are very weak, like in inert gases or the molecules in which there is less polarity. Non-polar molecules are having this kind of force, weak van der Waals forces of attraction. Okay. So
Okay.
these are like three types of forces, which like intermolecular forces, which we are going to deal in this chapter. Okay, now any question in this thing, this part?
No, not
Okay.
yet.